Okay, we have not had a lesson in a while, but here we go back into chapter 10. So starting off with chapter 10, we're going to start with circles and tangent lines. Pretty much all of chapter 10 is about circles. We're going to start with some basic terms you need to know for circles, okay? And I've got a whole list of them down here that we'll get to in just a little bit, okay? And then today we're going to focus on tangent lines for the most part, okay? So here we go. By now, I sure hope most of you know that this big thing here is a circle, okay? But if I actually asked you to define a circle, my guess is you probably could not do it. All right, so I want you to take a second and actually think of what is a circle. So what makes a circle a circle? All right, so think about how would you define circle? And a lot of times I get things like, well, it's, 360 degrees all the way around. So something like that. Is that a circle? Well, it follows that definition of 360 degrees all the way around. And obviously, no, it's not a circle. And so then I'll get people who say something like, well, it's got to be like, just, you got to be more even. Well, what in the world do you mean by more even? It's not very specific. Well, like that distance there can't be different than that distance there. Well, what in the world do you mean by that distance there and that distance there? And so you go, oh yeah, that's called a diameter. Okay, well what's a diameter? Well, the diameter is a distance across a circle, right? Well, that's kind of a problem. If we haven't defined circle yet, we can't say that the diameter is the distance across a circle. We can't use diameter to define circle and then also use circle to define diameter. So that's circular reasoning. Yeah, pardon the pun. All right, so we got to be careful with how we define things. So eventually, hopefully, we can come up with a definition, and that definition is going to lead us to a shape that looks like this. Okay, so what in the world is that definition? Well, it does have to deal with this point right here. Okay, so that's kind of important. But this point right here is not actually part of the circle. And actually, all this space inside of here isn't part of the circle either. A lot of times, maybe back when you're in elementary school, they'd say something like, color the circle blue. So you'd color all of this inside here blue. Technically, that's wrong. All of that inside stuff isn't part of the circle. It's the area of the circle, okay, which is a different idea. The area of the circle is the area, all of the square inches or square feet or whatever, that is contained inside of the circle. Technically, the circle is just this, I don't want to say line, but this curve. All right, this, literally, it's like just a connection of points all the way around the outside here. Okay, so what in the world is a circle? So let's give you a definition of a circle, and you need to know this definition. There are very few definitions that I ask throughout the year for you to know almost word for word. This is one of them. So the definition of a circle is all of the points that are the same distance from a center point. Now, that's not quite it, okay? Because if we just stopped right there, all of the points that are the same distance from a center point. Let me grab something right here. It's not quite a perfect circle, but it's kind of close. Well, it's not a circle at all, though, is it really? This is an orange, okay? But it's close to being circular, but this isn't a circle. Well, why not? Isn't this, if it was perfectly all the same, all right, wouldn't this be all the points that are the same distance from some center point? Well, it is, but it's not a circle because what's the problem with it? It's three-dimensional, okay? A circle is not three-dimensional, it's how many dimensions? It's 2 dimensions, okay? It's got a length, it's got a width, but it doesn't have depth to it, all right? It just kind of sits here on this piece of paper, on this plane, okay? It doesn't come off the plane. So let's go back to our definition. A circle is all the points, all these points right here, that are the same distance from this center point. If I measure the distance from here out to here, or if I measure the distance from here out to here, or if I measure the distance from here out to here, if I measure any of those distances, it shall always be the same. Okay, so a circle is all of the points that are the same distance from a center point, in two-dimensional space or in a plane. Okay, something along those lines. So that's your definition of a circle that you need to know, and you need to know it well. Don't be surprised if I actually ask that question on a quiz, like define a circle. All of the points that are the same distance from a center point in a plane. Okay, this curve is really just the connection of a bunch of points. Just like a line earlier in the year, way back at the beginning of the year, was just a connection of a bunch of points. This is the same thing. This is just a connection of a bunch of points, but it actually doesn't go straight, it actually curves. Okay, so that's our definition of a circle. All of the points are the same distance from a center point in a plane or in two-dimensional space. Okay, so that's our first word here that we need to define, circle. Next, we have center. Well, this point right here is the center of the circle. Now the weird thing is the center point is not part of the circle itself, okay, because it's not the same distance to the center. The distance from the center to the center is 0. It's not the same distance from the center as this point is. This distance might be, 3 inches or something like that. So the center of the circle is this point right here, but it's actually not a part of the circle. Okay, so I hope you understand that. Okay, now to name a circle though, so let's say when we have a circle, I'll just draw a real quick one here, and we have that, and let's call it A. A is that point right there. To name a circle, all we do is write circle A. Okay, can you guys see that? I'm going to zoom in a little bit here. Okay, so if I have this circle right here, okay, with a center at A, okay, this is point A, then the way we name it is we draw like a circle with a dot so we don't think it's an O, and then we put A. Okay, or B, or whatever other letter it might be. Okay, that's how we name a circle. Now there's one time where that can be a problem, and I'll talk about that later on. Okay, all right. Oh, going the wrong way here. Sorry. All right, let's go back to our picture here. Next term, radius. Okay. Now you guys are pretty familiar with a radius, and most of you, if I asked you what a radius was, you'd say, well, it's half the diameter. Okay, we have a slight problem there. We haven't defined a diameter yet. Okay, so we're not going to say it's half the diameter. Now that's a true statement. The radius's length is half of the diameter's length. But let's stay up in our picture here and talk about a radius. The radius is a segment from the center point to any point on the circle. Okay, that's a radius. A segment from the center point to any point on the circle. There you go. That's a radius. Okay, so put that in here, radius. And now the plural of radius, just so you know, radius is somewhat acceptable, but that hasn't been the usual definition. The usual definition for plural. It's radii. R-A-D-I-I. By the way, if you play Scrabble, it's a great word if you've got too many I's in your tray. Okay, R-A-D-I-I. All right, let's go to our next one, a chord. Okay, a chord. C-H-O-R-D, not C-O-R-D, C-H-O-R-D. Okay, and I know this might be a little bit hard to see because I did a lot of this in pencil today because I was using my compass to draw these circles in pencil. Okay, but chord. A chord. Definition of a chord is any segment that starts at one point on the circle and ends at another point on the circle. So maybe it starts up here and it ends over here. Okay, that would be a chord. Okay, it starts at one point on the circle and it ends at a second point on the circle. Okay, so that's a chord. Now, you can have longer chords and you can have shorter chords. Okay, I could start right here and I could come over here and that chord would be shorter. Or I could start here and I could come through here and come over to here, and that would be a longer chord. Okay, and they can be all different kinds of directions, but as long as they start on the circle and end on the circle, we call it a chord. Okay, so a chord is a segment that goes from one point on the circle to another point on the circle. Okay, next definition, diameter. Okay, a diameter. A diameter is just a chord, but it's a special chord. It's a chord that does what? It's a chord that passes through the center point of the circle. A diameter is just a chord that passes through the center point of a circle. So this whole thing here is called a diameter. Okay. Now, a diameter is twice as long as the radius. A diameter is the longest possible chord in a circle. You cannot form any chord that's longer than the diameter. But a diameter is a chord. It does start at a point on the circle and end at another point on the circle. It just goes through the center point. Any chord at all starts and ends on the circle. It doesn't have to go through the center point, but it could. Okay, so that's a diameter. Okay, next, secant. That's S-E-C-A-N-T. Secant. S-E-C-A-N-T. Let me zoom in here so you can see this, all these spellings a little better. Okay, there you go. So radii, R-A-D-I-I, secant, S-E-C-A-N-T, tangent. We've already talked about the term tangent in a previous lesson, but this is another use of the word tangent. Then over here we got a few other things. Point of tangency, T-A-N-G-E-N-C-Y, common tangent lines, tangent circles, concentric circles, C-O-N-C-E-N-T-R-I-C. Okay, so there's some other terms we're going to come back to here in a little bit, so hopefully you can get all those written down. All right, let's back out a little bit so you can see this again. Okay, so let's talk about a secant line. A secant line is a line that intersects a circle twice. Okay, a line that intersects a circle twice. So really, a chord, if we extended it out, would be a secant line. Or a diameter, if we extended it out, would be a secant line. I'm going to draw a separate one here. Okay. So there we go. That is a secant line. Okay. Goes through the circle twice. Secant line. Now there are times later on in this chapter we will call something a secant segment. Okay. A secant segment might, start right here. Start right here, go through here, and then come out to about here and stop. Okay? So even a chord could be considered a secant segment because it hits the circle twice. Okay, but that's a secant line. Next is tangent. Now this is different than tangent with trigonometry. Okay, tangent with trigonometry was the opposite side over the adjacent side. A tangent line, when we're talking about a circle, is a line that only touches the circle once. Before I draw it on here, I'm going to show you what I don't mean over here. Okay, so let's say I have a circle. Okay, it's kind of a bad circle, but this is not a tangent line. Somebody would say, well, but it only touches the circle once. You just said a tangent was a line that only touches the circle once, and it only touches right here. Right, Mr. Oates? No. Why not? Well, remember, lines go forever, right? So a line would come out here and it would eventually hit over here and it would touch the circle twice. So this is really a secant line. It's going to hit the circle a second time. Okay? And it's going to be in the same plane as the circle as well. All of these things are in the same plane. If you ended up having a circle, I don't know if I could maybe use this as an example. All right, pretend this metal ring is completely circular. Could I have a line that, kind of comes at an angle like this? Okay, kind of picture it this way. All right, and they're in different planes, and it only touches my circle once. Is that a secant line? Is it a tangent line? No, because it's not in the same plane as the circle. Okay, so hopefully you understand that. But this all has to be in the same plane. So a tangent line is a line that only touches a circle exactly once. So it's going to look something like this. Okay, right here we have a line or a point, and that's the one point where our line's going to touch. It's going to go out over there. It's going to come out over here. So hopefully you can see that. Okay, that's a tangent line. Okay, so these are your main terms. You got your center point, you got the circle itself, you got a radius, a diameter, a chord, a secant line, and a tangent line. Okay, now some people would say, well, how in the world could it only touch once? It looks like it touches lots of different spots in there. If we zoom in there real close, doesn't that touch in a lot of different spots, Mr. Oates? Doesn't it kind of touch here as well? And maybe like right here it's kind of touching a little bit. Well, because remember, a line is a point, and points are really, really technically have no dimensions. This thing I've drawn for the circle is too thick to really technically be a connection of points. But if we don't draw it thick enough, we can't see it. So because of the thickness, that's where we tend to have it looks like it touches multiple times, but it really only touches exactly one time right there. And by the way, we call that the point of tangency. That right there, okay, is called our point of tangency. It's the point where the tangent line hits the circle. Okay, so it's called our point of tangency. All right. Okay, now a couple more terms, and then we will be done with our terms. Then we got two theorems, and then I'm going to stop this video and we're going to continue on the second one. Now, let's go over here. Common tangent lines. Okay, I actually have this on another piece of paper. So, common tangent lines. Okay, common means it's going to work for more than one thing. All right, and tangent lines we've already talked about. So let me grab another piece of paper to show you what I mean by common tangent lines. And there's actually two different types of common tangent lines. Okay, there are common internal tangents and common external tangents. Okay, so internal obviously means inside, external means outside. Okay, so let me show you what I mean. I'm going to do common internal tangents with these two circles. Okay, so common internal tangents. Common tangent means it has to be tangent to both circles. So I have to have a line that touches this circle exactly once. I also have to have a line that touches this circle exactly once. It has to be the same exact line. So how in the world could we do that? Okay, well, let me show you with my pencil first. What we could do is we could kind of have a line that goes something like this. Okay, see that? Now, obviously, as I draw it, it's only going to touch the circle once. So let me line my ruler up and see if we can draw that in here. So we've got maybe right about here, touching exactly once. And right about here, touching exactly once. Get that again. Okay. Common internal tangent. And why is it considered internal instead of external? I'll give you a more technical definition here in a second, but internal goes between the circles. Okay, goes between the circles, inside the circles. Okay, we also have another one. Kind of, I don't know. Here, I'll try it that way. Kind of comes this way. So about like this. Okay, there's my point of tangency. Here's my point of tangency. Okay, so that's also considered a common internal tangent. Okay, all right, what about common external tangents? Well, external is obviously going to go outside. Well, what do you mean by outside? Well, this is kind of that inside space between the circles. It's not going to go through here, in other words. So it's going to look more something like this. Okay, so that's more what a common external tangent would look like. Let me zoom out just a tiny bit. Okay, that's a common external tangent. It's almost like a road. Okay, if these are wheels on a car, sometimes cars, especially if you think about like a racing car, one of those like drag strip type racing cars that have smaller wheels in the front and the big wheels in the back. Sometimes motorcycles might have different wheels sizes in the front and back or something like that. Well, the road acts like a common external tangent where each tire is touching the road. Okay, you have a second common external tangent as well. It looks something like this. Okay. We have our point of tangency here, and our point of tangency here and there. Okay, so that's our common external tangent, our second one. If your circles are different sizes, the common external tangents will eventually meet out here. If these circles were exactly the same size, then the common external tangents would be parallel to each other. Okay. All right, so let's get a more technical definition though for common internal tangent and common external tangent. Okay, if we took a segment and connected the center point of this circle to the center point of this circle. Okay, I'm going to draw a dotted segment here just so you can kind of don't get it confused with all the other things that are going on. But if we draw this segment, okay, and if I also do that over here on these circles, I draw this segment. Okay. Well, what do you notice is going on here? Okay, the common internal tangents, which are these ones up at the top, these are common internal tangents, and these common external tangents. The common internal tangents intersect this segment right there. Common external tangents never cross this segment. Now we have to refer to it as a segment because if it was a line, this line would keep going, and eventually out here the common external tangents would hit that. Okay, so we always refer to this as a segment. So the segment connecting the center points. If the common tangent crosses that segment like it does here, then those are common internal tangents. And if the common tangent does not cross this segment, then it's a common external tangent. Okay? So that's the difference between a common internal tangent and a common external tangent. All right, well, what about the last two terms we have? Okay? Tangent circles and concentric circles. I don't have really good pictures of these, so I'll draw them kind of real quick. Tangent circles. Actually, I'm going to come back to one more thing on those common internal tangents here in a second. But tangent circles and concentric circles. So what do we mean by tangent circles? Well, just like a tangent line only touches a circle once, a tangent circle or tangent circles are circles that only touch each other one time. So it might look something like this. Okay? So there we go. Those are tangent circles. Or maybe we have something like this. Okay? And then something like this. Okay, and those might be tangent circles. Those are internally tangent, because one circle is inside the other one. These are externally tangent. Okay? Real quick, actually, using this example. If I snuck a line right through here, right through that spot, that's a common tangent line, right? Is it common internal or common external? Okay, remember coming back to this. Okay, common internal, common external. Okay, so what in the world would this one be? Well, if I take the center point and the other center point and I draw that segment, does the tangent line cross that segment? Yes, it does. So that would be considered a common internal tangent. Okay, that's really the only possible common internal tangent. Okay, if I did the same thing here, okay, right here, tangent line. Is it common internal or common external? Well, there's my two center points. Did it cross that line? No. So it's common external tangent. Okay? All right. In this case, there aren't any common internal tangents. Okay? There's only one common external tangent. In this case, there's only one common internal tangent. There's actually two common externals. If I drew one right here, another one right here. Okay? When you build a snowman, all right, that's made up of tangent circles. Okay? You got tangent circle here and here. And then another one, another bigger one down here. Okay? Now, this one is not tangent to this one. But these two are tangent, and these two are tangent. Okay, at these points here and here. Okay, this, you might have some girls who own some earrings that look like that. They've got these kind of hoop earrings. It might look something like that. Okay, so you see this type of stuff somewhat frequently in real life. All right, and then finally the last one, concentric circles. Okay, concentric circles. If you know a little bit of Spanish, this can help. Cone, chili con queso, chili with cheese. Cone means with. Centric, center. So circles with the same center point. Okay, circles with the same center point. So what do I mean by that? Okay, let's draw a real quick sketch of this again. Maybe something like this. Okay, circles with the same center point. So that point there is the center of the smaller circle and the center of the bigger circle. And I can even draw another one in here, you know, something like that. So kind of like a target or a bullseye, an eyeball, a donut, you know, the wheel on a car, or whatever. Okay. Now the only problem we have with concentric circles, we talked about this earlier, is how do you name them? Okay. So if I got a picture like that and I say, well, circle A. Which circle A are we talking about? They're both considered circle A because remember the way we name a circle is we use the center point to name the circle. So this can get a little confusing. We don't run into this very often. So in this case, you might just say something like big circle A and little circle A. Or something like that, okay? But they're both considered circle A, and that can be confusing, okay? All right, two quick theorems, and we're done with this video. All right, theorem 10.1. Zoom out a little bit. All right, theorem 10.1 is this picture right here. What we have is we have circle D, we have a radius DC, and we have a line here, line AB, which passes through point C. Okay, I'm not going to prove this theorem to you, but it says that in a plane, okay, so this has to be in the same plane. You can't have a line going up and down like this through point C, something like that. Okay, they have to be in the same plane. But in a plane, if line AB is a tangent line, then it has to be perpendicular to radius CD at C, the point of tangency. And you can also do it backwards. If a line is perpendicular to a radius at the point of tangency, all right, then it has to be a tangent line. Okay, so it works both ways. If a line is tangent to a circle, then it is perpendicular to the radius at the endpoint on the circle. Okay, you obviously can't be perpendicular here, all right, because if you drew a line going through here that was perpendicular to D, it would be a secant line. Okay, so it's got to be perpendicular to the endpoint of the radius. Which endpoint? The one that's actually on the circle, not the one at the center. If this is a right angle, then you know it's a tangent line. If it's a tangent line, then you know it's a right angle, and it works both ways. Okay, so this is an if and only if theorem. The way your book says it is this. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius at the endpoint of the radius on the circle. Okay, so that's going to be important as we go into some examples later on. Okay, theorem 10.2. If you get two tangent segments, okay, instead of lines, these are segments, but knowing that they're segments doesn't really change things much. They're still only going to meet the circle at exactly one point. And if I extended them, they would be a tangent line. Okay, so in other words, you can't do something like this and say, well, would that be considered a tangent segment? Because, you know, it's a segment that only hits the circle once. No, if I extended it out, it would not be a tangent line. Okay, so a tangent segment is just part of a tangent line. Okay, so now from theorem 10.1, we know that if I draw the radius, okay, and if I do that again from here to here, I draw the radius to the point of tangency, then according to theorem 10.1, this has to be a right angle. And this has to be a right angle. Okay, by definition of a circle, AB is congruent to AD because all of the points are the same distance from the center point. And then next, I'm going to draw segment AC in here. We know by the reflexive property of congruence that segment AC is congruent to itself. So what do I have right now? I have angle, side, side. We know that angle, side, side doesn't work unless the angle is a right angle. And if it's a right angle, we rename it HL. All right, so hypotenuse, yep, it's across from the right angle. Across from the right angle. Leg, yep, leg, yep. Okay, this triangle down here is congruent to this triangle up here. So therefore, by CP/CTC, this segment is congruent to that segment. And that is what theorem 10.2 says. If two tangent segments begin at the same exterior point, then these segments are congruent to each other. Okay, so if we know that BC and DC are both tangent segments, and we know they begin at point C, the same point, then automatically they have to be congruent to each other. That's what theorem 10.2 is telling us. Kind of interesting, if you draw this, thinking back to our previous chapter, you get this and this congruent to each other, but not congruent to the radius. We have a kite. Okay, so if I were to draw BD in here, I would get perpendicular diagonals, and I could find area that way, and so on. But we do end up getting a kite in this case. Okay. All right, that is it for the first lesson in first video in lesson 10.1, terms, and then these two theorems. The next video we're going to do just deals with a lot of examples of how we use them.